Hey guys, today we'll be solving equations. We're going to really focus on multi-step equations, what we learned the process yesterday, the distribute, combine like terms, move the variable, add or subtract, multiply and divide, what you learned in 8th grade. That will help you solve any equation that they throw at you in algebra. There's a couple more problems, a couple more terms, a couple more variables that they throw at us in algebra, but basically it's the same thing as 8th grade, just a little bit harder. We're also going to look at types of equations today. So one solution, which is our most common type of solution, no solutions, and infinite solutions, or infinitely many solutions, what they call it at the high school. To jump right into it, we're going to jump into the review of concepts here, or a warm up, and we're going to start this first problem by distributing, because that's our first step. So you have to distribute everything in the parentheses there. I'm going to write it out to the right side here so that I have more space. I'm going to write it out here. So we have that negative times 3x is negative 3x, and negative times 5 gives you a minus 5. We then are going to be doing this 2 times x and this 2 times negative 2, which is going to give us a 2x minus a 4. And that plus 14 stays there. So now, solving this problem, we're going to move on to combining like terms. Like terms are things with either the same variable or both of them don't have a variable, which we call constants. So right here we have negative 4 and 14 both don't have a variable, so we can combine them. So negative 4 and a 14 we can combine to get a 10. So I drop everything down here. Negative 3x minus 5 is equal to a 2x plus 10. It's a positive 10 because that 14 was positive, and we just took 4 away because it was minus 4. I know it says subtract 4, but that's the same thing as saying negative 4. So now I have to get all my variables to the same side. I have to move my variables. Now you can subtract 2x on both sides. That's a perfectly fine way to do it, but I'm going to be adding 3x because that deals with less negatives then, and negatives are where a lot of students mess up. So I try to eliminate that wherever I can. So we're going to add 3x to both sides. I drop down this minus 5. This negative stays with that 5. And then I have a 5x plus a 10 here. Now it's just a two-step equation. We need to add or subtract and then multiply or divide. So I'm going to subtract this 10 on both sides to get a negative 15 is equal to a 5x. Then divide both sides by 5. I get negative 3 equals x. So x equals negative 3. And we're done with the first problem, which is probably the most complicated problem on this warm-up. This next one, we're going to just simply multiply by 3, which is the opposite of dividing by 3, on both sides. I get n plus 2 is equal to a 30. And then I subtract 2 on both sides to get 28. Then our last problem, we have no distribution. We have no like terms to combine because I can't combine this 7y and this 1, or this 2y and this 14, because one has a variable and one does not. So we have to move our variable. So to move our variable, again, you could subtract 7y from both sides, but I'm going to subtract 2y because it's going to give us a positive number. 5y minus 1 is equal to a 14. I then have to add 1 to both sides to get 5y all by itself. It's equal to a 15. Divide by 5. Divide by 5. And 15 divided by 5 is 3. There's a warm-up. Let's go ahead and dive into the first type of problem, and then we're just going to work through every type of problem you'll see today, and then we'll be done. So let's look at this first type of problem. We're going to follow the exact same steps for every single one of these problems, which is don't call me after midnight, distribute, combine like terms, move your variable, add or subtract, multiply and divide, every time in that order. So step 1, we're going to have to distribute. So I distribute negative 3 to both terms here. Negative 3 times x is a negative 3x. Negative 3 times negative 3 is positive 9. That's equal to a 9 minus 3x. Now you might notice something yet already, but if you don't, we're going to then have to, but there's no like terms to combine, we can't combine these, we can't combine these, so now we have to move all our variables. We'll have a negative 3x over here, or a negative 3x over here, so I'm going to add 3x. And then you're going to see here, wait a second, those cancel out. Oh no, I have no variable. what on earth should I do? You should just drop down everything. So let's drop down 9 is equal to drop down 9. Then you ask yourself, wait a second, is 9 equal to 9? Yes. And if it's true, if it's yes, if that is a true statement, then your answer is going to be infinitely many solutions. That's what the high school uses. We used to use infinite, or the infinity symbol. In 8th grade, infinitely many solutions is the same thing. You also might see something that says all reals. That means infinitely many solutions as well. Now that you know that, let's go ahead and dive into the next type of problem. In this type of problem, this is like our typical problem we'd see. This is like the most common type of problem. Still going to follow those same steps. Distribute that negative 2 to both terms. So I'll have a negative 2x minus a 6 is equal to that negative 15 minus a 4x. So now I look to combine any like terms. Nothing to combine here, nothing to combine here. So I move on to moving my variable. Moving our variable here, you could either add 2x to both sides because that's the opposite of negative 2x, or you can add 4x to get rid of it on this side. I'm going to add 4x. You can add 2x to both sides. You'll still get the same answer. But if I add 4x, I'll get a positive number in front of my x because negative 2 plus 4 is 2, a positive 2. And if we're trying, I recommend trying to eliminate any negatives that we can get rid of. So now it's just a two-step equation. I add 6 to both sides, and I get a 2x is equal to a negative 9 divided by 2 on both sides, and I get x is equal to a negative 9 halves. Now this is important. It's okay to have a fraction as an answer. It's okay to have a decimal as an answer. It's okay to have x equals 0 as an answer. That's still a one solution problem. They'll try to trick you with that. They'll make you think it's no solution, but it is. If I get x equals 0 as an answer, that is a one solution answer. So make sure you know that. Make sure you're aware of that as we solve through these problems. Let's look at the next one. This problem is going to help us explore the no solution answers. So step 1, distribute that negative 4 to both terms. So I have a negative 4x plus a 12 is equal to a negative 4x plus a 20. So now I need to move all my variables to both sides because there's nothing to combine. I have no like terms on the left side or the right side to combine. So I'll move my variable. I add 4x here. I add 4x here. Those cancel out. And I get 12 is equal to 20. Now we ask ourselves again, because our variables canceled out, okay, is 12 the same thing as 20? No. Since that's not correct, that's going to give us a no solution answer. Most of the time they'll want you to write no solution. That symbol, 0 with a line through it, works as well. Now that's not 0. That's no solution. Make sure you know that. Let's look at our next type of problem. 2 more problems, folks. We're killing it. This is a problem I want to go over because this negative right here out in front of that parentheses messes up a lot of students. Whenever you see a negative in front of a parentheses, remember it's a negative 1. So you need to distribute that negative 1 to both terms. That's the very first thing I would do if you ever see a negative in front of parentheses. It's so commonly missed. It's easy to miss, and negatives are the most missed thing in algebra. So distribute that negative, and you get a 3x. Negative 1 times 4x is a negative 4x. Negative 1 times a negative 7, because remember that negative and that subtraction sign in front of that 7 makes it a negative 7. Negative times a negative is a positive. So that's a positive 7 equals 21. So now we need to combine like terms. Well, we have a 3x and we have a negative 4x. So we can actually combine those. So let's go ahead and combine those. 3 minus 4, because the x's just are there for, they're just, the variables are just there. We're still going to have to combine like terms. They're both the same variable, so we can combine them. 3 minus 4 is negative 1, and you still have that x on it. Plus a 7 is equal to a 21. Well, now it's a two-step equation. We subtract 7 on both sides, and we get negative x, or negative 1x, is equal to a 14. But I don't care what negative x equals. I care about what positive x equals. So I'm going to multiply or divide both sides by a negative 1 Doesn't really matter if you divide or multiply. We're just essentially getting rid of this negative and making that 14 negative. So now it's x equals negative 14. That's our actual answer. Let's look at our next problem. Okay, folks, last problem, and then I'll touch on one more point, and then we're done. So step 1, distribute. Drop everything down that you didn't distribute. 5 times a 2 is a 10. 5 times a negative 2x is a negative 10x. So now we're looking at like terms to combine. There's nothing to combine on the left. On the right, even though they're both 10, one has a variable, one does not. So we can't combine those two. But we can combine this 8 and that 10 because both of them are constants. Neither one has a variable. So I'm going to combine those two and drop everything else down. 3 minus 5x is equal to an 18 minus 10x. And now we're simplified. Now I just need to move my variable all to the same side. Remember, if you're ever stuck, that's probably the step you're on. I'm going to add 10x to both sides so that we don't have to deal with any negatives. And I get a 3. Negative 5 plus 10 is a positive 5, so it's plus 5x is equal to an 18. I subtract 3 on both sides because now we're just at a two-step equation, and my habits take over at this point. And then we divide both sides by 5, and we get x equals 3. Notice those last steps are just the same problems that we were solving before, those two-step equations. And then you're done. X equals 3. Bing, bada, boom. The last thing I want to touch on is remembering slope-intercept form. Slope-intercept forms are y equals mx plus b. It doesn't go away. It stays in algebra. Sorry about you. We also have to understand how to get variables all by themselves, which you can do. That's an answer on the activity. Anyway, getting our variables all by itself. To turn something into slope-intercept form, we're trying to get this y all by itself. So we're trying to get rid of this y. Well, we're trying to get everything away from y, so it's all by itself. So I'm going to work like we just did, outside in. So I'm going to get rid of this 2x to start. So to get rid of a 2x, I'm going to subtract 2x. But I can't just subtract 2x from a 12. That's not going to work. They're not like terms. So I'm just going to stick it over on that side. So I have a 12 minus a 2, why did I write 3? 2x. And you can flip-flop those around if you want. Just make sure that negative sign stays on that 2x. But y is not all by itself yet. We still have this negative 3 out front. And it's right in front of the y, so how do we get rid of a number that's right in front of our variable? We divide it. So we're going to divide this side by negative 3. And then here's the trick. You have to divide this whole side, everything over here on this right side, by 3, by negative 3. So we're going to divide that 12 by negative 3, and we're going to divide that negative 2x by negative 3. So 12 divided by negative 3, super easy, negative 4. This is a little trickier, but don't overcomplicate it. What's a negative divided by a negative? A positive. So that's just our positive plus sign. 2 divided by 3 is just 2 divided by 3. And then you have an x, so put an x on there. Technically, to turn this into slope-intercept form, we want that in front of our 4. But, I mean, to be honest, both of these are fine. Because you got y all by itself. We're going to practice more with those in the upcoming days. That's the last thing we're going to do. Those are called literal equations. Super fun. Hope that helps. Good luck on your activity today. If you need help, let me know. See you tomorrow.